Hello, morning, my dear students. Today, I am going to discuss the first chapter of plus 2 physics, uh, electric charges and fields. Okay, electric charges and fields. Now, you already studied in the previous classes or heard about electric charges. Now, in this chapter, uh, first of all, I am going to give the concept of an electric charge or idea of an electric charge. Clear? Electric charge. Okay. Now, we know that uh, the matter has so many properties. Mass is a property of matter. Length is a property of matter. Volume is a property of matter. Therefore, matter has so many properties. This pen have a mass, is a property of this pen. It have a color, is a property of this pen. It have a length, is a property of this pen. It have a volume, is a property of this pen. Similarly, electric charge is a property of matter. Clear? I simply give the first of all, I give a simple definition, very simple definition. Suppose a person asks you what is an electric charge. Then you can say it is a property of matter, like mass, length, volume, etc. Okay, so simply an electric charge is a property. Now, next we are going to check which type of property, of matter. Clear? Okay, now first of all, I give a simple definition, very simple definition. Now, I am going to give a clear concept of electric charge. Now, I already uh, defined, I already gave a simple definition, that is to say, properties of matter. Electric charge is a property of matter like mass, volume, length, etc. Now, okay, now I will give the an interesting concept of electric charge. You already know that all matters are made up of atoms and molecules. Clear? And the atom consists of a centrally placed nucleus, and the electrons are revolving around the nucleus. Correct. This this is already you studied in the previous classes, like 8th, 9th, 10th, etc. And the nucleus consists of protons and neutrons. Okay, and the protons have a positive charge, and electrons have a negative charge. Clear? Okay. Now listen here, my dear students. Now, suppose I place the positive charge here and a negative charge here. This is positive charge and this negative charge. What happened? That these two charges will attract each other. That is, this move in this direction and this move in this direction. Clear? Suppose I place here a positive charge, proton, and a proton. Two protons are placed at a small distance apart. What happened? This will repel each other. This move in this direction, this move in this direction. This two opposite charges always attract each other, two equal charges always repel each other. Clear? Okay. Now, at this time, the only force exists is gravitational force, and the physicist does not any idea about any other force. Okay, at that time, the only force exists is the gravitational force, and we know that gravitational force is always attractive. Therefore, this may be Therefore, this is all okay. This is okay. This is attractive force, but this is repulsive force. Therefore, this is not gravitational force. Therefore, the physicists understand this, that there is this is another type of force. Okay, you know that, you know these two are charges. Therefore, this is the force between charges. Therefore, the force between two charges is, they understand that. Physicists understand that the force between two charges is not gravitational, because it's not attractive. This because it is not attractive. Okay, therefore, then uh, then he they introduced a new type of force called electrostatic force. Therefore, the force between two charges is called electrostatic force. Okay, therefore the therefore this force, the force between proton and proton, is electrostatic force. Electrostatic force. The force between proton and electron is electrostatic force. The proton is a positive charge particle, electron is a negative charge particle. Okay, therefore the force between two charges is electrostatic force. Okay, then what is the force of electrostatic force? Electric charges. Okay, therefore this electric charges, the one more property of electric charge, that is, this electric charge produce electrostatic force or gives electrostatic force. Clear? That is, two charges produce, or two charges gives a force, that is called electrostatics. Therefore, I will complete my definition about electric charge. First simply I say electric charge is a properties of matter. Which type of property? That electric charge gives electrostatic force. Therefore, electric charge is a property of matter which gives rise to electrostatic force. Therefore, I complete my definition. That's all. That is, an electric charge is a property of matter which causes or which gives rise to electrostatic force. Clear? Electric charge is a property of a matter which gives rise to electrostatic force. Simple. An electric charge is simply, if someone asks to you, what's electric charge? You can say electric charge is a property of matter which gives rise to electrostatic force. Okay, some property of matter which gives rise to electrostatic force is called electric charge. This is the electric charge. Okay, and two equal charges always repel each other, two opposite charges always attract each other. Clear? Therefore, I simply define the electric charge. Okay, once more I will explain this. That is, an electric charge is simply a properties of matter or property of a matter which give rise to electrostatic force. Clear? Now I just give the properties of electric charge. Okay, I am going to explain the properties of electric charge. Properties of electric charge. Properties of electric charge. Listen here. But first of all, or mainly there are three properties of it. First of all, I give what is the electric charge is additive in nature, first property, and second, electric charge is the property that is quantized, and third one, electric charge is conservation. This is the three properties. First property is electric charge is additive in nature. Second property, electric charge is quantized. And third property, conservation of electric charge. Clear? I am going to explain the first property. Okay, that is electric charge is additive in nature. First property. Listen here. Suppose we have a body. This body consists of the charges 3 coulomb, 5 coulomb, and minus 2 coulomb. Clear? Suppose we have a body, and the body consists of charges 3 coulomb, 5 coulomb, and minus 2 coulomb. Simply, and according to this property, the total charges in this body is the sum of this individual charges. Algebraic sum of these individual charges. Therefore, total charge capital U is equal to 3 coulomb plus 5 coulomb minus 2 coulomb is equal to 3 plus 5, 8 minus 2 is equal to 6 coulomb. 2 points. I will explain 2 points, only 2 points. That is, the charge of the unit of electric charge is coulomb. And charge is represented by the symbol small q or capital Q. Clear? Small q. What is the unit of electric charge? Coulomb. 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 And it is represented by the symbol small q or capital Q. Okay. Then let us explain this. That is, electric charge is additive in nature. Okay. Listen here. Suppose we have a body consists of the charges 3 coulomb, 5 coulomb, minus 2 coulomb, etc. Then total charge of the body is this plus this plus this is equal to 6 coulomb. Okay, therefore therefore electric charge is additive in nature. This is the first property of matter. Okay, that is, suppose the total charge inside a body is the sum of individual charges inside the body. This is simply the first property. Like masses. Suppose a body consists. Suppose we have a body. That body contains the mass 3 kilogram, 5 kilogram, 6 kilogram. Then total mass contained in this body is the 5 plus 3 plus 6 is equal to 14 kilogram. The same way, the total charge inside a body is the sum of individual charges inside that body. That is the first property. Clear? Okay. Suppose a body consists of large number of charges, then total charges inside the body is the sum of individual charges, or algebraic sum of individual charges inside the body. That is the first property. Now I am going to discuss the second property. That is, electric charge is quantized. Can you got it? I think. Can you got it? Clear. Now listen here, my dear students. Now I am going to explain the second property. That is, electric charge is quantized or quantization. Listen here, my dear students. Suppose you all students know about the play cricket. During cricket play, we take the run 1, 2, 3, 4, and 6. Clear? Suppose during one running, we take the run 1, 2 run, 2 times this 2, 3 times 3, and if the ball touches the boundary, the run is 4. If the ball go outside the boundary, it is 6. Okay, therefore the run is 1, 2, 3, 4, and 6. Do you know half run is there? No, half run is not possible. Run 1, 2, 3, 4, and 6. 1.5 run is there? No, 1.5 run is not possible. 4.5 run is there? No. Only integer number run is possible. Clear? Only integer number of run is possible. Half run is not possible. 1.01 run is not possible. 4.01 run is not possible. 3.05 run is not possible. Only 1 run, 2 run, 3 run, 4 run, 6 run. Similarly, in the football, okay, football, suppose one team hit the ball inside the post, they get 1 goal. 1.5 goal is not there. 2.5 goal is not there. Okay, in a similar way, a body, the total charge of a body is 1e, 2e, 3e, 4e, etc. 1.5 is charge is not there, not exist. 2.5 e charge does not exist. It's not possible. The charge is only is 1 electronic charge, 2e, 3e, 4e, etc. That is the total charges inside a body is only an integer multiple of a unit charge or integral multiple of a unit charge. That charge is only exist. 1.5 E is not exist. 2.5 E is not exist. 3.5 E is not exist. The 1 E charge is possible. 2 E charge is possible. 3 E charges is possible. 4 E charges is possible. Therefore, the total charge inside a body is always an integral multiple of unit electronic charge. And this electronic charge may be the charges of a proton or the charge of an electron. Okay. Therefore, this is called the quantization of electric charge. This may be written as Q is equal to plus or minus NE. Very important property. Q is equal to plus or minus NE, where N is equal to 0, 1, 2, 3, 4, etc. Clear? Got it? Clear. That is, according to quantization of electric charge, the total charge of a body is the integral multiple of a basic charge. That basic charge is the electronic charge of a proton or a electron, and it is given by E is equal to 1.6 into 10 raised to minus 19 coulomb. The charge of electron is 1.6 into 10 raised to minus 19 coulomb. Okay, now I am going to explain the last property, that is conservation of electric charge. Okay, last property, conservation of electric charge. Conservation of electric charge. Conservation of electric charge. Let us listen here. Suppose we have a body. We have a body with the charge. Can you see this? With the charges 3 coulomb, 5 coulomb, and minus 2 coulomb. Okay, this is at the time 9 a.m., 9 o'clock. 9 a.m. I have a body with the charges 3 coulomb, 5 coulomb, and minus 2 coulomb. Okay, then what is the total charge here? First, according to first property, what is the total charge? 3 plus 5 minus 2 is equal to 3 plus 5, 8 minus 2, 6 coulomb is the total charge. Okay, now at some another time, that is at 4 o'clock, 4 p.m. 4 p.m. this charges, this is 4 coulomb, this is 6 coulomb, then this is minus 4 coulomb. Therefore, total charge here, total charge, according to first property, 4 coulomb plus 6 coulomb minus 4 coulomb is equal to 4 coulomb. So, 6 coulomb. Clear? What do you understand from this? Here, 6 coulomb. At 9 am, the total charge of this body is 6 coulomb. At 4 pm, the charge distribution is changed, but the total charge is 6 coulomb. Okay, therefore, the total charges of a body is always conserved or remains constant. The total charge of a body remains conserved. The charges here, the charges is 3 coulomb, 5 coulomb minus 2 coulomb at 9 am. That is at 4 pm, this 3 coulomb will change to 4 coulomb, 5 coulomb change to 6 coulomb, minus 2 coulomb change to minus 4 coulomb, but the total charge is 6 coulomb. Here the total charge is 6 coulomb. Therefore, the total charge of a body is always a constant, remains constant. The charge distribution may be changed. But the total charge remains conserved or constant. This is called the conservation of electric charge. Okay. Now let us just say the 3 properties of electric charge. One is charge is additive in nature. Second one is charge is condensed. Third one is charge is conserved. Okay. Now I just use all ideas. That is, I just conclude this. That is, first of all, I define the electric charge. What is meant by an electric charge? An electric charge is a property of matter which gives rise to electrostatic force. Then I am going to explain the property of electric charge. First property is charge is additive in nature. Second property is charge is condensed. And third property is charge is conserved. Thank you.